Good morning, viewers. This is today I am going to explain Laurent's half-shade polarimeter. This is very important for the semester examination for the second year students, and as well as the students those who failed, they can easily listen this class, and if they prepare the books, they can easily write the examinations. So please watch it, subscribe it, and please like it also. Thank you. Let me start it. Laurent's half shade polarimeter. So this is the Laurent's half shade polarimeter, and Laurent's polarimeter also called as saccarimeter. Right? Polarimeter are also called as saccarimeter. So these polarimeters devices used to calculate the concentration. Concentration means what? Suppose you have taken 1 liter of water and I have added 2 or 3 spoons of salt or sugar. Then 2 or 3 spoons. 3 spoon, 2 spoon means we don't know how many grams. If you have to calculate those values in terms of grams, we should use saccarimeters or polarimeters. So this is the importance of this polarimeter. And now, first we have to remember the diagram. And by looking the diagram, whatever components it contains, if you write the name in terms of sentence, that gives the explanation of diagram. Right? So please see the diagram. See, this is the diagram. In this diagram, it is a source. Monochromatic source we must use. And lens, its name is a polarizer. So it is a source, lens. It is a polarizer. Let me denote with N1. It is a half shade, and it is a tube which contains solution. And it is analyzer. Let it is denoted with N2. It is a circular scale. This is a telescope. Okay. See the source, analyzer, polarizer is polarizer, half shade, tube or active substance. Its name is active substance. Analyzer. It is a circular scale. Circular scale. It is a telescope. This is the diagram. And here the source must be monochromatic source. So from monochromatic source, light comes in all direction, and a light which is coming in this direction, it may go in this direction, it may go in this direction. If there is no lens, so lens can do the light which are moving in this direction, they can make to move in this direction. So it render the rays into parallel rays. And falls on it is the unpolarized light. Falls on the polarizer and it produces polarized light. Means it converted into two rays, ordinary ray and extraordinary ray. Ordinary ray can be stopped by the Kendall balsam, and extraordinary rays moves in this direction, falls on the half shade and enter into the active substance, means in the tube, and next enter into the Nico analyzer number N2 analyzer, and finally falls on the scale. It will be viewed by the telescope like this. And here, before knowing about this, first we should know that what is half shade. How does it works? Half shade, how it is appearing, it is not like this. Half shade is always in circular shape. It is like this. It is half shade. And half shade is prepared with the half wave plate. Half wave plate. I think you know the half wave plate and quarter wave plate. Half wave plate can introduce path difference lambda by 2 or phase difference pi. Path difference lambda by 2 or phase difference pi. It is a move. And here what we have to do, we have to take two half wave plates. One is blank to quartz, other is blank to the glass, right? Two half wave plate. Those are the semicircular shaped plates. Semicircular means like this. Let it is a quartz plate and one more semicircular plate. That is a glass. It is quartz, and join them together. They forms like this. Okay. Now it is what? It is glass and this is quartz. So glass plate don't have any optic axis, but quartz plate they have the optic axis. So their optic axis parallel to this diameter, like this. Okay. But when the light is coming along the interface or along the joining, then this half and this half appears equal brightness. And suppose when the light is coming from either in this direction or from this direction or from this direction or from this direction, then only one side can appear brightness, other side cannot appear brightness. Means other side appears dark. That dark is called shading. So that is name of that, because of that only half shade name has come. Okay. So like this. Now see. Suppose the light is coming in this direction, and let me divide it into two parts. Let us A, C, and these are R, S. So when light is coming like this, this light divides. This light is divided into two parts. So that is what parts you know? One is O ray and E ray, ordinary ray and extraordinary ray. So let me say x dash axis and y dash axis. Suppose the light is coming like this, right? Then it is converted, it is splitted into E ray and O ray. let OA travel in this direction and extraordinary travel in that direction. And the result actually present in this direction. But instead of moving in this direction, what happens? They moves in reverse direction. Why? Because it is a half wave plate can introduce the path difference phi. It can introduce phase difference phi. Phase difference phi means a light which is moving in this direction, it can be reversed. It can be reversed. That is the meaning of pi. And a light which is moving in this direction, it can be reversed. Then now it is reversed in this direction and it reversed in this direction, and the resultant can be get in this direction. So that means we have come here and the light is moving in this direction. Path O ray travels by this E ray in this direction, and their result actually has to move in this direction. But instead of moving in this direction, they move like this because O ray can be reversed, E ray can be reversed. That means E ray travels like this, O ray travels like this. Their resultant will be like this. That means here the light is entering into the quartz and leaving from the quartz. No light is entering into the glass plate. So that is the reason it appears very bright. It appears brightly. It cannot appear brightly. It appears shade dark. Right? Suppose the light is coming like this. Light is coming like this. Then what happens? This light can come like this. Then it appears dark and it appears bright. Only half part appears darkness, half part appears brightness. When both part appears brightness, when the light is coming along the diameter, then only along the joining, then only those two can appear brightly. Right? So this is the working of half shade. So this half shade we have to keep in between tube and as well as polarizer. And see from that. Suppose the light is coming in this direction and it is converted into which ray? E ray. O ray can be stopped here. And E ray comes in this direction and falls on the half shade of traveling half shade enter into the tube which contain optically active substance. So here what happens? Suppose light here one vibration will come. One vibration. Let the light particles are vibrating like this. When enter into this tube, instead of moving like this, it has slowly changed the direction. See, like this. So how long it is traveling in the tube? Instead of moving like this, vibrating like this, the vibration slowly changes. Means they rotate like this. Like instead of like this, they start rotating in this manner. Okay. So then I travel to the analyzer. Analyzer it is a parallel to this one. You cannot see anything. If you see the rotated light, you must rotate analyzer. Analyzer can also rotate about its own axis. Okay, like this. First, what we have to do? We have to do the experiment with water. First, take this tube, clean it with water, and add water, and fill this tube with water, and come this side. Come this side, and observe. So when these analyzer and polarizer are parallel, then the light can appear this side. Easily it appears. Okay. And no need to rotate. So here it is circularly, it is a circular scale. That means the scale is like this. But I have drawn this line. But you must assume it is like a circle. So that is why see a circular scale. That is a name. Okay. So circular scale. And see here and note down the values. Then you can get the two values. One is let the first value is theta 1. Next value is theta. Where it contains water. Now remove the water and fill it with active substance. Active substance means solution. Means take the water and add 2 to 3 spoons of the sugar or salt. And now keep here. Why do you have to use this one? Why do you have to make it as bulk Suppose when the concentration is when the solution contains air bubbles may form in the middle of the solution. Then the light which is coming here, and if it is traveling through the air bubbles cannot make to rotate the vibrations. Only solution can make the rotations. So then we cannot get the exact answer. If you have to get the exact answer, you must do like this. So whatever air bubble present, this simply goes and fill this gap. This gap cannot disturb the light which is coming, which is entering into the solution. So that is the reason why this is prepared in this manner. Okay. And now see here, light is coming from the source, monochromatic source, and this enter into the this tube and into the analyzer. But here what happens, now it is a parallel to this one. So before it we have observed it is a brightly. When you keep here an active substance which contains a solution of sugar or salt, then the rotation changes. How does it changes? Suppose here the rotations are like this. It is a polarized light. When enter into here, their rotation changes. Their vibrations starts rotating like this. In this manner. Then these vibrations cannot be parallel to this one. Then you cannot see that side any light. So for this, what you have to do, slowly rotate this analyzer by looking through the telescope. Slowly rotate it, and when you reach a perfect brightness, there stop it. Which one? Analyzer stop it. How much angle is rotated can be seen through the circular scale, and stop there and note down the values. Let those angles as theta 1 dash and theta 2 dash. Let them those angles theta 1 dash and theta 2 dash. Difference, take the difference of these two angles and you can get it as a theta, and difference of these two things you get theta. Average of these two theta plus theta by 2 is given as theta, or take it as theta 1 dash, theta 2 dash, theta 1 double dash, theta 2 double dash, and theta 1 dash minus theta 2 double dash is theta, theta 2 double dash minus theta 2 double dash is theta, theta 1 and theta 2, theta 1, theta 2 average is theta. Where we have to substitute the theta? You must substitute the theta in the formula S is equals theta by L into C. Or you have to draw a graph. Why? How? See here, graph. So take the concentration and x-axis, theta on y-axis, and replace this solution with a different solution. Do the experiment with the different solutions, and then you get a straight line. Take the slope of this solution with a straight line as a theta by c, and substitute in the formula S is equals theta by L into c. Theta by c and substitute, and L is the length of the tube. L is length of the tube. C is the concentration. Theta is the angular rotation. How much vibrations are rotated? That can be calculated by the formulas, by this one. And S is the specific rotation. S is called specific rotation. So like this, S is equals theta by L into C. So first, what is the specific rotation? That is V1. So please remember these things. A diagram is very, very important, and what you are observing, write them in terms of words. That is enough. And let me explain the specific rotation definition. S is equals to theta by L into C. L is the length of the tube, active substance. C is the concentration, how much sugar or salt is added into the water. That is the concentration. Theta is a rotation of vibrations, how much angle they have rotated. Suppose if you take L is equals to 1 decimeter and C is as a 1 gram per cc. C is concentration 1 gram per cc. Cc means cubic centimeter. In 1 cubic centimeter 1 gram present. So when the vibrations are moving through the active substance, means the solution, with a length 1 decimeter containing concentration 1 gram per cc, then they produce an angle, certain angle theta. So this is called specific rotation. Rotation produced by the solution when vibrations are rotated through 1 decimeter of 1 gram of cubic centimeter solutions. That is called specific rotation. S is equals theta by LC. So this is the formula. Okay. So and this formula. So this one can be used for Laurentz offset polarimeter. So this is a friend Laurentz offset polarimeter. So don't forget sharing, subscribing. Please subscribe and share the link to your friends. Thank you.